So we've done some half equations. Now let's try and ask the question, what's the point of splitting an equation up into two halves and then putting it back together? Well, the simple reason is so that you can balance it. So if I have an equation here, say for example MnO4 minus plus H plus Fe2 plus goes to Mn2 plus H2O and Fe3 plus, it's very difficult to balance. We've got to balance it in terms of the number of atoms, Mn's, O's, H's, Fe's, and we've got to balance it in terms of the number of charges, and that becomes very tricky. So let's have a look at how we can do that. We're going to take one of the reactants on the left, MnO4 minus, and we're going to try and work out, we're going to try and follow what that does. Well, Mn is in there, and Mn, the only place that Mn goes to is Mn2 plus. So we're fairly safe to say MnO4 minus is turning into Mn2 plus. What on earth is going to happen to the O's? We can never balance the O's at all. So how do we balance these O's? We need something on the right hand side with O's in it, otherwise we're never going to balance the oxygens. So what do we have on the right hand side with O's? So we've got water. So water must also go onto the right hand side. So now the Mn's go to Mn2 plus, that's the only place for them to go. The O's go into waters, that's the only place for them to go. I've got a slight issue that I've got H's on the right. Where do they come from? They must come from something. What on the left has got H's in it? H plus. So H plus must be on the left. So from starting with MnO4 minus and working out that it must make Mn2 plus, where do the O's go? They must go into water. Where do the H's come from? They must come from the H pluses. I've now got a chance of balancing it. Half equations, remember, always need electrons adding in. If there's no electrons in your half equation, it's not right. So let's have a look what I've got. I've got one Mn, I've got one Mn. I've got 4 O's, I'm going to need 4 H2O. I've now got 8 H's, I'm going to need 8 H pluses. I'll need electrons in there to balance up the charges. How many charges I've got on the left? 1 minus and 8 H plus is 7 pluses. On the right, there are only 2 pluses. So I'm going to need some electrons on the left-hand side to balance up the number of charges. I said I'd got 7 plus on the left and only 2 plus on the right, so I'm going to need 5 electrons on the left. The MnO4 minus has gone from oxidation state something to something. Well, in here there are 4 2 minuses, which is 8 minus, 1 minus left over. It's gone from plus 7 to Mn2 plus is plus 2. Okay, so the Mn must be plus 2 to leave 2 plus overall. There's nothing else there. It has been reduced because the oxidation state has gone down. If it's been reduced, it is an oxidizing agent. So if something is reduced, something else is oxidized, so the thing that's reduced is causing the other thing to be oxidized. It's an oxidizing agent. What else have we got in there that we've not used so far? Fe2 plus. What does that go to? Fe3 plus. Well, that one's easy. Which side are electrons and how many? Just 1 electron on the right to leave 2 pluses on either side. The Fe2 plus has gone from oxidation state plus 2 it's gone up to +3. So it's been oxidised. If it's been oxidised, something else is reduced, so it is a reducing agent. Now then, we need to put these two half equations back together again. Now, when we put the two half equations back together again, the whole equation, the overall equation as it's called, can't have any electrons in it. They need to cancel out. So if we have a look at how many electrons are in this one, the top one, there are 5 electrons on the left. In the other one, there needs to be 5 electrons on the right, so that when we add everything on the left and everything on the right, that cancels out. So I need to make 5 electrons on the right. So I times everything through by 5. 5 of them, and 5 of them, and 5 electrons. Now what I can do is I can combine these two equations together. I'm going to take this equation and I'm going to take my other equation I'm going to add everything on the left and everything on the right. So on the left, of this one, there's that. On the left of the other one, there's that. So I'll put that on the left as well. So now I've taken everything from the left of both half equations, and now I'm going to take everything on the right of both half equations and because I'm multiplied through by 5, we have 5 electrons on each side. And because I've got 5 electrons on each side, they can cancel. So I'm going to delete them. And that's why I multiplied through the second half equation by 5, so that I'd have an equal amount of electrons on each side, so that I can now delete them from each side, and I've now got an overall equation. Let's just check it balances. 1 Mn on the left, 1 Mn on the right, 5 Fe's on the left, 5 Fe's on the right, 8 H's on the left, 8 H's on the right. Number of charges on the left, 1 minus and 10 plus and 8 plus is 17 plus. Number of charges on the right, 2 plus and 5 times 3 is 15, 2 add 15 is 17 plus, and it balances. You need to write the overall equations to balance VO3 minus, Zn and H plus going to V2 plus, H2O and Zn2 plus. I'll give you a clue. VO3 minus, what can it go into? Well, it can only make V2 plus. Where are the O's going to go? They've got to make some water. When I make some water, where are the H's going to come from? H plus. So I'm going to have VO3 minus, H plus going to V2 plus and H2O. I need to balance all of the atoms and then put electrons on one side. The other half equation, Zn, can only go to Zn2 plus. I need to put some electrons in, and then I need to balance the electrons on either side by multiplying through so that there's the same number of electrons in each half equation. Then I add the two half equations together and cancel the electrons. So I add everything on the left of both, everything on the right of both, and the electrons cancel. Then I've got to do the same with the other one. MnO4 minus and H plus Cl minus goes to Mn2 plus H2O and Cl2. Let's have a look. MnO4 minus, what can it form? It can only form Mn2 plus. What else must it form? It must form water, otherwise there's nowhere for the O's to go to. It's made some H's in the H2O, so I'm going to need H plus on the left. So I'm going to have MnO4 minus and H plus going to Mn2 plus and H2O. I'll need to balance the atoms and then put some electrons in. And then the other half equation, Cl minus goes to Cl2. I'll need to balance the Cl's, put some electrons in on one side, and then multiply each half equation through by a number so I get an equal number of electrons on each side. I'll then add everything on the left of both and everything on the right of both, and cancel the electrons. This one, I'm going to leave you to it. You should get the gist by now. And the fourth one, and the fifth one as well, and the sixth one. So hopefully you should be able to balance those equations. And finally, there's a definition. An oxidizing agent. What's the definition of an oxidizing agent? It's an electron acceptor. A reducing agent is an electron donor. Let's try and work that through a little bit. An oxidizing agent is itself reduced. It causes something else to be oxidized, so it is reduced. Do you remember oil rig? Reduction is oil rig, oxidation is loss, reduction is gain. So if it's reduced, reduction is gain. It's being reduced, it's gaining electrons. The best word for something that gains electrons is an acceptor. A reducing agent causes something else to be oxidized. So a reducing agent causes something else to be reduced. So it itself is oxidized. So a reducing agent is oxidized. Oxidation is loss. So a reducing agent loses electrons and gives away, loses or donates those electrons. We may need to come back to that, or you may just need to learn it, and then you've got some past paper questions to do.